Have you ever wondered how a remote control can change the channel on your TV without any physical connection? It's a question that might have crossed your mind. It's all thanks to something we call electromagnetic waves. These waves are present in our daily lives, doing their work invisibly and silently. Whether it's the radio signals carrying your favorite tunes or the data that lets your phone access the internet, it's all powered by these unseen waves. But what exactly are these electromagnetic waves? At their core, electromagnetic waves are all about energy. Imagine a pebble dropped into a still pond. The ripples that radiate from that point of impact travel across the water's surface, spreading the energy of that initial drop. Electromagnetic waves function in a similar fashion, only they are spreading energy through the vast expanse of space rather than a small pond. These waves are generated by electric charges, but not just any charges. They come from charges that are vibrating or accelerating. Think of plucking a guitar string. The string vibrates, creating sound waves that travel through the air. In a similar way, a vibrating or accelerating electric charge generates electromagnetic waves that travel through space. But space isn't the only thing these waves can traverse. Electromagnetic waves have the ability to pass through certain mediums as well. Air, for instance, is a medium that allows these waves to pass through. That's why you can use your cell phone indoors, because the electromagnetic waves can pass through the air and walls to reach the cell tower. Glass is another example. Light, which is a form of electromagnetic wave, can pass through glass. That's why you can see through your windows and eyeglasses, and why you can read this text on your screen right now. Even water can act as a medium for certain electromagnetic waves, which is why you can still receive radio signals while you're out boating on a lake. In essence, electromagnetic waves are packets of energy that are constantly in motion, traveling through space and various mediums. They are created by charges that are not at rest but are instead vibrating or accelerating. And while they may seem invisible and intangible to us, their effects are very real and tangible. They power our technology, light up our world, and even keep us warm. So, electromagnetic waves are energy traveling through space, but there's more to them than just that. An electromagnetic wave isn't just a simple line of energy, it has a specific structure. Now let's take a closer look at this structure, which is as intricate as it is fascinating. The electromagnetic wave consists of two main components that oscillate perpendicular to each other. These are the electric field and the magnetic field. Imagine a wave in the ocean. As it travels forward, the water's surface rises and falls. In a similar fashion, these two fields rise and fall, but in different directions. The electric field oscillates vertically, while the magnetic field oscillates horizontally, yet both fields move forward together, creating the wave. Now let's talk about three essential aspects of an electromagnetic wave: wavelength, frequency, and amplitude. The wavelength is the distance between two consecutive points in a wave that are in the same phase. Picture this as the distance between two consecutive crests or troughs in our ocean wave. In an electromagnetic wave, it's the distance between two peaks of the electric or magnetic field. Frequency, on the other hand, is the number of complete wave cycles that pass a given point in a second. If our ocean wave hits the shore 10 times in a minute, its frequency is 10 per minute. In the case of electromagnetic waves, we usually talk about frequencies in terms of hertz, where 1 hertz equals 1 cycle per second. Amplitude is the height of the wave, or how far the field strays from its undisturbed state. In our ocean analogy, it's the height of the wave from the water's level when it's calm. In an electromagnetic wave, it's the maximum distance that the electric or magnetic field strays from zero. By playing around with these three aspects, wavelength, frequency, and amplitude, we can create different types of electromagnetic waves. Each type has its unique properties and uses, from radio waves that carry music to your car's radio, to X-rays that let doctors see inside your body. These components give each electromagnetic wave its unique properties. So, the next time you're tuning into your favorite radio station or getting an X-ray, remember the intricate structure and the fascinating components of the electromagnetic wave that make it all possible. Electromagnetic waves come in a variety of flavors, forming what we call the electromagnetic spectrum. This spectrum is a continuous range of wave frequencies that include, in order of increasing frequency and decreasing wavelength, radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Let's start with radio waves. These waves have the longest wavelength and the lowest frequency. They are commonly used in communication systems like television and radio broadcasting. When your favorite song comes on the radio, it's being transmitted to your car's antenna through radio waves. Microwaves, on the other hand, have a shorter wavelength and higher frequency than radio waves. They're used for things like satellite communication and, you guessed it, heating up your leftover pizza in the microwave oven. Next up, we have infrared radiation. These waves are even shorter and more frequent than microwaves. Infrared radiation is what we feel as heat. It's also used in remote controls and thermal imaging cameras. Then we have visible light, the only part of the electromagnetic spectrum that our eyes can detect. It's what makes the world around us colorful and vibrant. Ultraviolet radiation, or UV light, has an even shorter wavelength and higher frequency than visible light. While it can cause sunburns and skin cancer, it's also used in sterilizing equipment and producing vitamin D in our bodies. X-rays, with their high frequency and short wavelength, allow us to see inside the human body without invasive surgery. They're most commonly used in medical imaging. Finally, we have gamma rays, the electromagnetic waves with the shortest wavelength and highest frequency. These are produced by nuclear reactions and certain types of radioactive decay. They're used in cancer treatment, sterilizing medical equipment, and even in food irradiation to kill harmful bacteria. So, whether it's a radio broadcast or an X-ray scan, it's all thanks to the electromagnetic spectrum. Electromagnetic waves have changed the way we live and continue to shape our future. These waves are the lifeblood of our modern technology, touching every aspect of our lives. Let's delve into some of the areas where these invisible powerhouses have made a significant impact. Consider telecommunications, a field that has revolutionized the way we communicate. Electromagnetic waves, especially radio and microwaves, are key players here. They carry voices, pictures, and data across the globe in a matter of seconds. From the simplest phone call to the most complex internet data transfer, none of it would be possible without the power of electromagnetic waves. Now let's step into the world of medicine. Medical imaging technologies like X-rays and MRIs rely heavily on electromagnetic waves. These tools allow doctors to look inside our bodies without a single incision, leading to early and accurate diagnoses. Electromagnetic waves are also at the heart of radiation therapy, where they're used to destroy malignant cells and treat cancer. The exploration of space, too, owes much to these waves. They carry information from distant planets and galaxies to our telescopes, helping us understand the universe. Satellites use them to communicate with Earth, sending back images and data that aid weather prediction, navigation, and many other applications. But we're not stopping here. The potential of electromagnetic waves is vast and yet to be fully realized. Researchers are exploring their use in areas such as wireless power transmission, where electricity could be transmitted without wires. There's also talk of harnessing them for cloaking technology, making objects invisible or undetectable to certain types of detection systems. As we move into the future, we can expect electromagnetic waves to play an even bigger role in our lives. They've already transformed the way we communicate, diagnose diseases, and explore the universe. Who knows what other revolutionary applications await us? So the next time you use your phone or microwave, remember the invisible power of electromagnetic waves. They're not just scientific phenomena, but everyday miracles that make our modern world possible. So, we've taken a fascinating journey into the world of electromagnetic waves. We started off by understanding the basics, that electromagnetic waves are oscillating electric and magnetic fields, traveling through space at the speed of light. We appreciated their omnipresence, from the light illuminating our world to the radio waves carrying our favorite tunes. We then delved into the anatomy of an electromagnetic wave, exploring the intricacies of its electric and magnetic components, their perpendicular relationship, and how their oscillation results in the wave's propagation. Our exploration took us further into the vast spectrum of electromagnetic waves, from the long, languid radio waves to the short, energetic gamma rays. We understood that the wavelength and frequency define the type of electromagnetic wave, and that each type has its unique place in our universe. Finally, we marveled at the power and potential of electromagnetic waves. We discussed how they're harnessed in countless ways, from microwaving popcorn to providing Wi-Fi connectivity, from powering solar panels to enabling medical imaging. In short, we've seen that electromagnetic waves are not just abstract physics concepts, but tangible forces that power our everyday lives. We've come to appreciate the unseen yet crucial role they play in our universe. And with that, we've demystified the invisible energy that's all around us, the electromagnetic wave.